Hello everyone, this is Aaron, and today I'm going to show you a demo of one of my projects. This is basically a command line interface for a STM32 microcontroller that is running FreeRTOS as the real-time operating system. Basically, if you take a look on the right side, um, basically, FreeRTOS provides a framework that allows to register our own commands, and this is the flow that we have to follow in order to do that successfully. And the first step is to provide a function that implements the command's behavior, and this is basically a C function. So for every command there should be a C function implementation that implements the behavior. And after that, we map the command to the C function. And once we are done with that, we have to register all the available commands with the library. Basically, there's an API that accepts a specific structure that abstracts the command information. And finally, we run the command interpreter. And before jumping into the demo, I would like to show you the software architecture, just to understand how this works. And on top, there's a console task that handles the user input um, via your device. And basically, the user types the command, and then the task will process every any input and will create the command. And the task has the responsibility to pass that command to the framework. And if this command is a valid command, the framework will call a C function that we have provided previously. So for um, any of these green boxes is a C function implementation that implements the command behavior. And you might see these boxes. This is another layer. This is a BSP layer, and I added this layer just to do some pre-processing before calling the ST HAL layer. So you know that this HAL layer is a driver layer, or it is also called MCAL if you work in the automotive industry. And all right, so let's see what else. So this is a serial communication. So you have to have a serial connection between your host and the microcontroller. And you might know that the signal levels are different. So you need a serial converter between the microcontroller and the host. All right. So let's jump into the demo, into the fun part. We have to open the CL device, and if you're working in a Windows environment, you can use Terraterm or PuTTY. But if you're working in a Linux environment, we can use Picocom or Minicom. I'm gonna use Picocom this time. And then if you type enter, you would see the command prompt. And what else? If you press Control plus L, this will clean the screen. We can also type enter. We can also press enter. So let's begin with the first command, the most common command or the most useful command probably. This is the help command. This will list all the registered commands. So let's start with this one, the statistics. This will show us a table with task information that you might be familiar with. Stats, Basically, we see here all the present tasks that are being created and the state. I mean, if the task is running, if the task is ready or blocked, waiting for an event or something like that. And the third column from left to right is the priority. Then we see that the stack remaining, the CPU usage, and the runtime. And I think that's it for this command. Let's move on to the GPIO commands. Maybe you might be familiar with the GPIO, and there are two operations, very common operation. We can write to a GPIO pin, or we can also read from a GPIO pin, and that's what those commands um, are doing here. So let's maybe I'm gonna share another screen here where you can see the LEDs. I have two LEDs, the green and the red one. And I would like to, for example, I would like to write a DL value of 1 to the to the uh, to the red LED. The LED is connected to, let's see, the port B. So we have to type B here, and the next the second parameter is the GPIO number. So this is connected to, let's see, connected to the GPIO pin number 1, and then we're going to write a high value. And as you can see, the LED is turned on, and we can also read the state. We can read the port B, and then the GPIO number is 1. We can also, for example, we can press tab, and this will output the previous command, which is a very cool functionality. All right, so we can write, for example, to the same GPIO port, but a different state, just to see if there's any difference. And we can also read the state again, read the same port, the same pin number. So we would see the other state. So that's pretty simple. So let's jump into a different command. The echo command, you might be very familiar with this probably. This will just output the string that is being passed as a parameter. So echo hello, and we see the same output. Echo hola, we have the same, we see the same thing. I think that's it for that command for now. All right, so this is the PWM commands. You might know that we can change the frequency and the duty cycle of a PWM signal, and that's what we do here with these commands. This command changes the frequency, and this one changes the duty cycle of a given channel. So you might notice that we don't see the channel here, and the reason for this is that um, my project settings, or my project, what I have in my project is just one timer, and if you change the frequency of that timer, all the channel frequency will change. So we would see that behavior in a moment. I'm gonna open the Logic Pro 2. I already have some channels connected, and then if I press the button play, we're gonna see some signals that are already running. So here the goal is to change the signal properties. I'm gonna change first of all, I'm gonna change the frequency. So we type PWM F for frequency, and then the frequency. So 1 represents 1 hertz, and then you can see there that the frequency has been changed. And what else? We can go back to the previous or to a higher frequency. Let's see, 1000. and we see what we are expecting, right? Okay, we can change the duty cycle. PWM D for duty cycle, and then the duty cycle in percentage. So one is for 1%, and then the channel for the first channel. So we can now see the behavior there because we have to change the time here. So you can see the first channel, the first duty cycle has been changed, and we can also uh, go back to the previous duty cycle that was 50%, and we see the same signal again. And I think that's it for the PWM commands. Very simple, very useful when you are controlling a motor, for example. You want to test something really quick. And the next command is the heap command. The heap command will display the free heap memory. Heap, and then the heap size, the remaining, and the minimum ever existed in the application. What else? The clock command. So in STM32 microcontrollers, there's some very specific names for the clocks. We have the system clock, the APB1, and the APB2. Some for peripherals, another for the timers. And in order to understand more about this, you have to take a look at the clock tree in the user manual. And what else? We have the ticks command. So the ticks command will tell you some tick information. And this is about the tick rate in the RTOs, in FreeRTOS. And here we have ticks and the runtime, but in seconds. Sorry, I had to stop the video, but I was saying that there is an RTC or real-time clock that is present in many microcontrollers, which is very useful to schedule events or to set alarms. And we have here two commands to do some kind of real-time clock operations. We have the RTC get command. This is to get the current time present in the RTC registers. And we also have the set command. This allows us to set a new time. Those are pretty simple and very useful for now. I'm gonna create more commands in a different release, but for now, I think it's enough. Um, so let's see what we can do with those. We can type RTC get and get the current time right now. Uh, we can also set a new time. Let's see, uh, 20, then I don't know, maybe 20 again, and then 20 for seconds. This follows the structure of hour, minutes, and seconds, and the time format is 24 hours. And we can, just to make sure that the new time has been written successfully, we can read it again, right? RTC and then get, and we have to see the time that we have set. And what else? Let's see. Let's go to our last command. And this is the version command. This is just output the current version of the project. So right now we are in 1.0 version, and hopefully in the future I'm gonna create more releases. But for now, I think it's okay. Thank you, everyone. Thank you for listening to me, and take care.